In this video, let us solve more problems based on trigonometric identities. Well, we have a problem which reads this way. Prove that cot to the power 4 theta plus cot square theta equals cosecant to the power 4 theta minus cosecant square theta. So we've got cotangent and cosecant in this problem. That's all, no other trigonometric ratio that we've got. So what we have to do is we have to write this in terms of square. So cot square theta the whole square plus cot square theta, right? So now as we write this, we also have to remember this identity, one of the most basic trigonometric identities, that is 1 plus cot square theta equals cosecant square theta. Now it's not this identity that's going to play a role directly here, but it is cot square theta equals cosecant square theta minus 1, right? Which we get it from this. Cot square theta equals cosecant square theta minus 1. The 1 goes to the right hand side. So now if we can continue from there, now here we've got cot square theta inside. So cot square theta equals cosecant square theta minus 1. We have to write whole square because it is whole square, and plus cot square theta again. So cot square theta is cosecant square theta minus 1. So now what we've done is we've converted the cotangent into cosecant. All that we have to do is we just have to do some minor adjustments and get it to this specific exponents. That's all we have to do. So I think we just have to expand this, and nothing much is to be done. So here we've got, let's consider cosecant square theta as a and 1 is b. So we have a minus b the whole square, which is a square plus b square minus 2ab. So cosecant square theta the whole square is cosecant to the power 4 theta, that is a square, plus b square is going to be just 1, minus 2ab. 2a is cosecant square theta, b is just 1. So plus cosecant square theta minus 1. So the 1 and 1 gets cancelled, and we've got cosecant to the power 4 theta as it is, and minus 2 cosecant square theta plus cosecant square theta is nothing but minus cosecant square theta. So here is the RHS. So we've got it. We've started off from cot to the power 4 theta plus cot square theta, made it squares. Now time to remember an important identity here. 1 plus cot square theta equals cosecant square theta. Why this identity we have to remember right now? Because you see what is involved in the problem. You've got a cot and you've got a cosecant. Quickly go back to your memory reserves and see what you've got there to have cot and cosecant in the same line. So this is the equation that you get. Once you have this equation, modify it slightly to suit this problem, and then there we go. So we've got it here. So we proved that cot to the power 4 theta plus cot square theta equals cosecant to the power 4 theta minus cosecant square theta. So that ends this problem. Let's quickly solve another problem before we end this video. Alright, here we've got another problem which says prove that sine theta plus cosecant theta the whole square plus cos theta plus secant theta the whole square equals tan square theta plus cot square theta plus 7. So now we've got this. We just have to expand, that's all, and then expand and hope that we get something like this, because there's nothing otherwise we can do. So let's expand and see. Sometimes it's about just doing what we can and then seeing in the middle where we stand and then analyze according to the right hand side. Sometimes we can't just plan off from the first step. So here we've got it all in terms of a plus b the whole square. So a plus b the whole square is a square plus b square plus 2ab. Apply that here. We get sine theta plus cosecant theta the whole square is sine square theta plus cosecant square theta plus 2 sine theta cosecant theta plus cos square theta plus secant square theta plus 2 cos theta secant theta. So the first thing that we can group is sine square theta plus cos square theta, right? Because that's going to be 1. So let's group that, and then we can group cosecant square theta plus secant square theta, right? And we can have 2 times sine theta cosecant theta. You know that sine theta is a reciprocal of cosecant theta, right? So you can write it as 2 times sine theta into 1 divided by sine theta, because cosecant theta is 1 by sine theta, plus 2 cos theta. Again, secant theta is nothing but 1 by cos theta. Or you can write cos theta also as 1 by sec theta. That's up to you. So sin theta gets cancelled. Cos theta gets cancelled. So we've got 4 already. So sin square theta plus cos square theta is 1. And then we have cosecant square theta plus secant square theta. Right? So now, okay, let's come back to this a little later. Let's write this as it is. Cosecant square theta plus secant square theta. And we've got 2 plus 2. And we have 1 plus 2 plus 2, which is cosecant square theta plus secant square theta plus 1 plus 2 plus 2 is 5. So now we can, stop and look into the right hand side and see that we need a 7 here, but we've got a 5. So the 7 should be somewhere there, all right? So now we also need a tan square theta and a cot square theta. So what is cosecant square theta? Now go back to the identities and see what can link cosecant and secant to tan and cot. Well, it certainly is. Cosecant square theta can be written as 1 plus cot square theta, and secant square theta can be written as 1 plus tan square theta, and we write the plus 5. So 1 plus 1 plus 5 becomes 7, and we have tan square theta plus cot square theta plus 1 plus 1 plus 5, which is equal to 7, which is nothing but RHS. So here we've got it. So we proved that sin theta plus cosecant theta the whole square plus cos theta plus secant theta the whole square equals tan square theta plus cot square theta plus 7. It was all but simple trigonometric identity. You just had to use them. You just had to remember them and use them in the right places. That's all there was to do. So this concludes this problem as well as this video. I'll see you in the forthcoming videos with more problems based on trigonometric identities.